Welcome to chapter 3. This one's about functions. The first question here, rather the fourth question in 3.2, asks us to write a function called absolute. It takes x as a parameter. If x is greater than or equal to 0, you return x as is. If not, you return minus x. That's the absolute value function. Here's how you write a function. You have the def keyword. After that, you have the function name, an open bracket, a bunch of parameters separated by commas. Here we have just one, so there is no need for a comma. Then a close bracket. Following that, we have a colon. Enter a new line. You indent the new line, spaces away from any number of spaces, away from the def block, and then you start writing your statements. So here's the output. The absolute value of 6 is 6. The absolute value of minus 3 is plus 3. Moving to the next question, we're asked to write a function called checkodd. It takes x as the parameter. If x mod 2 is 0, then it's an even number. So it's not an odd number, so you return false. If not, you return true. Notice here that we don't have an else statement. This is because once the return statement gets executed, this particular function block returns. There is no further execution. It doesn't go to the next statement. That's why we can return false, and safely without using an else block, we can write another statement called return true, which will get executed if this if check fails. To see this in action, checkout of 2 should be false and checkout of 1 should be true. Welcome to the 8th question. Here we're given a single character and we have to return if that character is a vowel or not. A couple of things to note here. Assert is used to check that this condition is true. If it is, then nothing bad happens. The program continues to execute the next statement and it moves on. If this condition was to fail, then this message gets printed to the screen and the program exits. So let's see this first. See here, it's an assertion error and you need a string to be a single character. It's the same thing here. Let's comment these two out and run it again. Here you'll notice that U is a vowel, K is not, M is not, and I is. In fact, even if you were to change the case, the result would be the same, because our comparison is made by converting the character to a lower case first. Here's another one. The 9th question asks us to print the nth Mersenne number, which is of form 2 power n minus 1. The minus 1 is not associated with the power. So let's first look at the output. 1, 3 and 7. This expression here is evaluated like this. For those of you who are a bit rusty on operator precedence, the power operation runs first before the subtraction operation. So 2 power n happens before the minus 1. That's about it as far as the 9th question is concerned. Here's a 10th question. Given a 4-digit number, square the first 2 digits and the last 2 digits. So given a number like 1210, whether it's positive or negative, doesn't matter. We have to return 12 square plus 100 square. Let's see this in action. So for both these numbers, we return the same value. Here are the steps. First thing, take the absolute value of the number. After that, get the top half, get the bottom half, and then square them and add them. If the number of digits is more than 4, then you'll have the top half greater than or equal to 100, because 9999 is the biggest one there. That's about it. Similarly, the smallest 4-digit number is 1000, which is why the top half should be greater than 9. You should have 10 at least. Welcome to the final problem in chapter 3. Given a number, we should return true if it is prime and false otherwise. So here is our assertion statement. Number should be greater than 0, since we are given that the number should be a positive one. 2 is the smallest prime number, so if number is 1, then return false. Finally, check every number between 2 and the square root of the number, both endpoints inclusive, which is why we have a +1 here. So just to jog your memories, square root of 17 is 4.123 something, right? If we have int of this is 4. That's what this program does. It starts with the number 2 and goes all the way to 4. Since 4 will not be included because range is an open interval as far as the endpoint is concerned, we add a +1, convert it to integer and add a +1. That's about it. It will check between 2 and 4, check if any number divides the given number without a remainder. If it does, the given number is not a prime number. If not, it's a prime number. Let's see this example in action. 5 is a prime number and 6 is not. This brings us to the end of the chapter.